Here is a lesson on multiple transformations in one function. So here's our function y equals 2 times the quantity of x plus 1 all squared. The first thing you want to do when you do these problems is identify who is your parent. So if we look at the equation, there is a squared here. So our parent is going to be a quadratic function. So quadratic function. If you remember the shape of a quadratic function, it's a parabola. It opens up. The parent function equation is y equals x squared. So in the first box here, I'm going to go ahead and create our parent function ordered pairs, and I'll graph those out. So we have our x, and then we have our y. So the values we're going to choose are 0, 1, and 2, negative 1, negative 2, and we're going to evaluate the function. So 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, negative 1 times negative 1 is 1, negative 2 times negative 2 is 4. All right, so let's go ahead and graph that parent. All right, so our parent function, our critical point is at 0, 0, and then our next order pair is over 1, up 1, and then over 2, up 4, and then left 1, up 1, negative 2, up 4. So there is our parent function graphed out. All right, now we're going to go ahead and graph our new function. So we need to pull apart who are our true transformations in this graph. The first thing is a multiplier of 2. It is in front of the function. It's outside the function, I call this. So it's a multiplier. It's changing your vertical axes. So that's your y by a multiplier of 2. So we call a multiplier of 2, it's greater than 1, a stretch. So it's going to change all of your y values by 2. We're going to multiply all of our y values by 2. All right, the other thing that's happening is a plus 1. This plus 1 is inside the function, and what that does, if it's inside the function, it's affecting the horizontal axis or the x-axis. So this is a horizontal shift, and since it's a plus 1, we have to think opposite, left 1. And so what we have to do is think about the horizontal axis or x-axis. You're going to be shifting all of your parent function x values left 1. So we're going to be subtracting 1 from all of the x's. All right, so now let's go ahead and find those ordered pairs. So in this case, we're going to take all of these x values and subtract 1. So 0 minus 1 is negative 1. 1 minus 1 is 0. 2 minus 1 is 1. Negative 1 minus 1 is negative 2. And then negative 2 minus 1 is negative 3. All right, now let's take care of the y values. We're stretching all of these y values. We're going to multiply by 2. So 0 times 2 is 0. 1 times 2 is 2. 4 times 2 is 8. 1 times 2 is 2. 4 times 2 is 8. All right, so here is our function. Graph down the purple. It's getting kind of messy here. We're going to graph all of these ordered pairs. So the first ordered pair is left 1, up 0. The next one is over 0, up 2. And then over 1, up 8. And we go negative 2, up 2, negative 3, up 8. All right. So we should see that our parabola is stretched up taller. If you notice from this point here is now stretched to there by a multiplier of 2. And then our critical point, which started at 0, 0, has now shifted 1 unit to the left. So our new critical point is at negative 1, up 0. That's called our vertex. So I did want you to identify who are your transformations. I'll just write them in shortened words. Left 1 unit, and then vertical stretch by 2. All right. Who is your critical point? It is a vertex point of -1 up 0. Your domain values is every number can be plugged in for x. Now your y values, your range, is everything above that horizontal axis. So the domain is all real numbers. And then your range is y has to be greater than or equal to 0.